Thank you very much. I'm Steve Barnett from Barnett Technical Services. We are primarily a distributor of scientific and engineering instrumentation, although we also do some consulting and training as well. We have about 30 years of experience. We are based in Northern California, and we focus primarily on advanced characterization and manipulation tools. With respect to additive manufacturing applications, we have systems for micro cleanup, for optical and chemical characterization, as well as physical and mechanical characterization. The first system I'd like to talk about is the MicroSupport Axis Pro. This is a benchtop micromanipulator for precise microsampling. It has XYZ motion control on a stage as well as two sampling arms. It's typically used for failure analysis, particle isolation, and precise microsampling. This is an example of the Milling Pro sampling tool that can remove imperfect printing from the surface of a part. In this case, you've got a soft polymer that's fairly elastic and is clearly attached to the surface. The Milling Pro sampling tool is like a flat-edge screwdriver with a hypersonic vibration. This can be used to separate the imperfect printing area from the part so that you have a smoother surface. We also work with AZTEC and their FTIR and Raman microscopes for chemical analysis of polymers. We offer everything from fairly simple, low-cost FTIR and Raman microscopes all the way to the most advanced Raman microscopes that are available on the market. MicroSupport also offers a system to measure the dynamic viscoelasticity of solids. Here you see a probe that's about 200 microns in diameter that rapidly moves up and down on a surface to calculate the elasticity of a solid. For more advanced nanomechanical testing, we also offer a system from AZTEC, which includes an AFM as well as a nanoindenter. One unique attribute of this nanoindentation system is that you can configure it with a Raman microscope to perform nanoindentation and simultaneously perform Raman measurements of the material after the indentation process. Finally, I'd like to talk to you a little bit about thermal conductivity. Now, you would normally not consider this an appropriate subject for a polymer session because polymers typically are thermally insulating. However, they do provide valuable physical properties such as flexibility that many products and many applications demand. And therefore, doped polymers are often used to confer desirable thermal properties. We work with Hot Disk, and one of their most popular products is the TPS2500S that performs these types of thermal conductivity measurements. The system is shown here on this tabletop. The sampling setup is shown right here, where you have a sensor that looks like the Kapton yellow sensor on the right side, and that is pressed between the material that you want to measure the thermal conductivity on. To give you one example, graphene nanoparticles are often doped and blended into polymers to confer thermal conductivity. However, to provide an increase in thermal conductivity, these nanoparticles must be oriented properly. So in the figure here, you see one example on the top where the nanoparticles are not oriented properly and there is no appreciable increase in thermal conductivity. At the bottom right of this figure, there is an example where the graphene nanoparticles are properly aligned, providing an increase in thermal conductivity. This is all from the reference that is shown on this slide. So thank you very much for listening. If you go to this website, you can download a copy of this presentation and also look for links to the products that were mentioned here, as well as some applications. You can contact us at the email address or the phone number that's listed here. Thank you very much.